Alright, so I want to pick up where we left off before, and that is that we found the solution to this using our calculator, the solution to that system of equations, and it turned out to be x equals 4 and y equals negative 3. And this was only possible because there was an inverse matrix to matrix A. And so we say that A was invertible. Now, with a 2 by 2 matrix, we can test when a matrix is not invertible. Now, let's just go ahead and take, for example, what we had in this particular problem. We had this 2 by 2 matrix, and fortunately A, I believe, was a 2 by 2 matrix. So we're just going to go ahead and use A. And it's 2 by 2, and that's okay. 2 by 2, 2 by 2, and I'm just going to put these values in there. 1, enter. 4, enter. And then we'll leave that one alone for a second. 12, enter. And then 6. Alright, so now if I were to go back over to here and put in negative 3 halves, negative 3 halves is negative 1.5, and enter there. Now, if I went out again, cleared out, and I did matrix A and did inverse, it gave me an inverse. So that tells me that that has an inverse. I'm going to go back again. See if I can do this quickly. No, I don't want to do that. I want to go back to matrices. Go back to edit matrix A. And instead of 1.5, this time I'm going to put in a 0. Enter. I'm going to quit out of that. And I'm going to do the same thing. I do second, enter to recall the last expression, and that has an inverse. So we're good there. So I'm going to go back to matrices, go over to edit, edit matrix A. Come down, instead of 0, I'm going to put 3 halves. 3 divided by 2, enter, and I'm going to go back to, sorry, I want to go back to quit out of that. Sorry, quit. And I want to go and run that again. This time, notice it gives me a singular matrix. A singular matrix on your calculator means that it is not invertible. And so the answer we could have found this way without knowing what else to do. But I'm going to talk about now how we would have gone about doing this using algebraic means. Now if I had put in 2 in there, it would have worked, just as the other ones. Now, fortunately, for a 2 by 2 matrix, we can tell if a 2 by 2 matrix or any matrix is invertible. It will not be invertible if its determinant is equal to 0. And the determinant is found differently for different types of matrices, but a 2 by 2 matrix is found by taking the difference of the diagonals, of the product of the diagonals. So what I do is I start up here in the top, and I'm going to multiply 1 times 6 and subtract from that 4 times x. So I would write that 1 times 6, or 6 minus 4x, and that will not be invertible when this is equal to 0. So I get the equation 6 minus 4x equals 0, and 6 equals 4x, and x equals 3 halves. And I say that that's much simpler than if I had done it using my calculator. Well, it happens to be that way for a 2 by 2. If this were a 3 by 3 or a 4 by 4 matrix, then the calculator is going to be much quicker, a much quicker way of finding that information. So remember, a matrix is not invertible when it does not have an inverse, and we can plug into the calculator and do A and use to the negative first power, or A inverse, and if we get a value or we get a matrix out of that, then it is invertible. If we get a singular matrix error, it means it's not convertible. I hope that's clear. So we'll look at hopefully some other examples of matrix algebra.